We'll answer a few of the questions from the practice problems for test 3 to give you some more explanation for how these things work, but in each case I don't have a lot of room to write, so I'll just answer part of the question in most cases. So for this first question, we're asked to label one angle theta, and of course that means the other angle will be 90 degrees minus theta, and then to write down the 6 trig functions for these two angles. What happens is that obviously we just use our SOHCAHTOA relationship, so I can write down sine and cosine of theta. To do that, I need to know the hypotenuse of this triangle, which I get from the Pythagorean theorem, so I won't show that here. Square root of 41 will be the hypotenuse. So the sine of theta, here's theta, is the opposite side, 4 over the square root of 41. And cosine is the adjacent side, 5 over the square root of 41. If we compare that to the sine and cosine of 90 minus theta, then we see the fundamental property of complementary angles that we've been talking about. If you're focusing on 90 minus theta, then the sine is the opposite over the hypotenuse, which is 5 over the square root of 41. And the cosine of 90 minus theta is the adjacent side, 4 over the square root of 41. So just as we had talked about in class, the sine of theta is the same as the cosine of 90 minus theta, and the cosine of theta is the same as 90 minus theta. In other words, since sine and cosine are cofunctions, and the two angles in a right triangle are complementary, then we see that the property that we talked about, the cofunctions of complementary angles are equal, is true. And so the same thing would happen if we looked at the secant versus cosecant of these angles and cotangent versus tangent of these angles, but I won't bother writing that down here. So another kind of problem we have is introducing this notation of inverse trig functions. So the idea of being able to draw a right triangle with an angle theta. Be sure you label the angle theta, because remember there's more than one angle in the right triangle, and sometimes people confuse themselves about which angle they're talking about. So in this triangle, the tangent of theta is 2/3, and so again with the Pythagorean theorem tells us that this side is the square root of 13, which we're going to need in a little bit. But the fact that tangent of theta is 2/3 is exactly the same thing as saying that theta is the inverse tangent of 2/3. So this angle that's labeled theta, we could think of that angle as being, well, we know that angle is the inverse tangent of 2/3. So when we answer questions about the sine of theta, we are actually answering the question, what is the sine of the inverse tangent of 2/3? And when we answer the question, what is cosine of theta, we're actually finding the answer to the cosine of the inverse tangent of 2/3. And these two questions are easy if we have the right triangle. So in this picture, the sine of theta is the opposite side over the hypotenuse, 2 over the square root of 13. And the cosine of theta is the adjacent side, 3 over the hypotenuse, 3 over the square root of 13. So it might be worth in your calculator to check, to do these two calculations, this calculation and this calculation. Those are easy to put in your calculator, and just check that you really do get values that are equivalent to 2 over the square root of 13 and 3 over the square root of 13, so that you can see why this works. You can really invent any fraction at all you want here for tangent of theta, and you should be able to do the same problem and check it on your calculator. So this gives you a chance to practice with problems that you make up on your own. The same idea can be applied even if we don't know the numbers for the sides of the triangle. So again, if we focus on this inverse cosine of x, if I use the letter theta to stand for the angle that's inverse cosine of x, that's the same thing as saying the cosine of theta equals x. And we know from our previous problems that we can draw this picture, as long as we don't mind using the letter x as a label. So here's the angle theta in a right triangle. If I want the cosine of this angle to be x in this picture, then I'm going to label the adjacent side x and the hypotenuse 1. Now the cosine of theta in this picture is equal to x over 1. And so this is true, and so therefore this is true. The question now is, what is the sine of theta? In other words, what's the sine of the inverse cosine of x? And to do that, I just look at my right triangle and I need the opposite over hypotenuse. So I'll need once again to use the Pythagorean theorem to find this missing side. And you should do that on your own if you're not sure how to do it. Make sure you get square root of 1 minus x squared. And so the sine of theta is the opposite side divided by the hypotenuse. So in other words, it's the square root of 1 minus x squared divided by 1. So this is my answer to the question. Finally, we have a whole class of questions like this, where we're given pieces of information about a right triangle, and we have to find the missing sides. And towards the end of this practice sheet, we all see that we can do the same thing even if the triangles are not right triangles, thanks to the law of sine and cosine. In each case here, I'm just going to find one of the sides. The missing angles are always easy in these problems because you have two of the three angles given. So if you know that you have a right triangle, and you know that one angle is x, then you know the other angle is 90 degrees minus x. If you have a right triangle and you know one angle is 40, then you know the other angle is 50. So the angles are not really the challenging part. The challenging part are the lengths of the sides. So let's pick a side. So I'll put a question mark here for the hypotenuse. And for the first triangle, the triangle on the left, let's find what that side is equal to. This is my angle that I'm focusing on. There is a relationship between that angle, this side, and this side. In other words, the angle, one thing I'm given and one thing I'm trying to find out. The 120 is the adjacent side to the angle x, and of course the question mark is the hypotenuse. So the relationship that I know is true is that the cosine of x is 120 divided by the hypotenuse, whatever that is. So if I algebraically solve that for the hypotenuse, I'll get that the hypotenuse has to be, the hypotenuse has to be 120 divided by cosine of x. And I could do something similar to find this side, starting off with the tangent relationship. And then similarly over here, let me do a different one here. I'll do a leg of this triangle. I might as well start with the 40-degree angle since that's the one that was given to me. For this 40-degree angle, the x is the opposite side and the question mark is the adjacent side. And so I know that the tangent of 40 degrees should be the ratio of the opposite side, x, to the adjacent side, the unknown. And again, if I solve this equation for the unknown side, then I'll find that the missing side is x divided by the tangent of 40 degrees. And I could do something similar to find the hypotenuse, just starting off with a different trig equation. So these two problems are very similar. The only thing that's different from these and previous problems is that we're actually using variables in our labels, but the work we're doing is exactly the same.